Infinite Insight Social can be used to explore relationships between items that interact in networks. These networks can be social, but can also be of other types, such as financial transactions between businesses, the flow of data between servers, or degrees of similarity between products. In this example, we have data about telephone communications and want to explore communities within the dataset, as well as communication between individuals. There are 3 different ways to create a social network analysis. We can build a social graph directly from a dataset, extract a graph from an existing model, or create a graph from a bipartite graph, which links different sorts of data, such as networks of customers and of the products they've purchased. For this example, we'll build a social graph from a dataset. First, we'll select the dataset we want to analyze. For this example, we'll use data from the samples folder created when SAP Infinite Insight was installed. Next, we need descriptions of the data to correctly identify the characteristics of the variables. We can do this by getting Infinite Insight to analyze the data and then manually validate the results, or by loading an existing description file. For this example, we'll load a description file. Here we can see the variables from the data source along with their details. Note that SRC is the primary key for the table. This column contains the phone numbers of customers initiating phone calls. Next, we need to specify the type of graph we want to create. There are 5 different graph creation modes available. Contact mode explores communication links between items in a dataset. Linked items must be of the same type, such as phone numbers or customers. In this mode, we can choose a minimum number of contacts required for creating a link, and specify if we're interested in directed or one-way communication, such as calls from person A to person B, or undirected communication, where calls from A to B or B to A are considered. Transactions mode explores relationships between items of different types, such as between customers and products. Proximity mode examines degrees of similarity between items. Nearest neighbors creates links between objects that are the most similar with regard to the variables being considered. For example, this mode could be used to identify different groupings of customers based on their purchasing behavior. Links Only mode links IDs from the source column to IDs of the target column. For this example, we'll use contact mode. In the column roles area, we can specify the variables for analysis. For this example, the appropriate source, target, and date variables were identified automatically. The links type option is specific to contact mode. Here we can specify if we're interested in the direction of communication between nodes when creating links, or if communication in either direction will count. For this example, we'll use directed mode. In the conditions for link creation area, we can specify a minimum number of contacts before creating a link, or select a wait column. In the time period area, we can set a beginning and ending date for analysis. For this example, we'll accept the default settings. Before creating a model, we can specify if we want to enable community detection and optimize megahub detection. Communities are subgroups within a dataset with more internal connections than connections to the rest of the network. Megahubs are individual nodes with a large number of connections, such as call centers. Detecting communities and megahubs can increase model quality, so we'll detect both. Note that we can specify settings for detecting communities and megahubs by clicking the ellipsis beside each option, but for this example, we'll accept the default settings. Optionally, we can add an additional dataset to our analysis to provide demographic information about the customers in our link dataset. This is known as a descriptive attributes dataset and can be set on the next screen. When the keys in the link dataset and descriptive attributes dataset don't match, it's necessary to also add an identifiers conversion dataset to map the columns appropriately. For this example, we'll use an identifiers conversion dataset and a descriptive attributes dataset. The conversion dataset will map the SRC column in our link dataset with the customer ID column in the descriptive attributes dataset that we'll select on the next screen. Next, we'll open the description file for the identifiers conversion dataset. Now we'll add the descriptive attributes dataset. Next, we'll open the description file for the descriptive attributes dataset. Here we can see all of the additional descriptive details that are available to add to our analysis. Now we'll add all of the available columns as descriptive attributes for our analysis. Here we can see a summary of our modeling parameters. Now we'll generate the model. Here we can see an overview of the modeling results. Note that 5 graphs have been created. Each graph represents a different level, moving from micro to macro, with individual customers at the lowest level and large communities at the highest level. Also note that all of the nodes are in the first repository. There are only nodes in a second repository when performing analysis analyzing links between 2 distinct populations. Here we can see details of the 5 chart levels that have been created. We can see that density is greatest at the 4th level, which groups customers into a small number of large communities. Now we'll view the charts generated by the model. Here we can browse and view communities or display individual nodes. We'll begin by viewing the community tree to see its structure. Here we can see information about the sizes of communities at the highest level, level 4. We can select a community to see the sub-communities within it. In this case, the community identified at level 4 has the same size as the community identified at level 3. Now we can see examples of communities identified at all 4 levels, with level 1 having a large number of communities with just a few members in each. Next we'll view all of the communities at the highest level. Here we can see all of the communities at the highest level, with the node size reflecting the number of members in the community. The arrows show the direction of communication between the communities, with the arrow width indicating the number of calls. We can see details about any community by selecting it. Now we can see more clearly the communication patterns between this community and other communities. At the left, we can also see information about the community, which came from the descriptive attributes dataset we added to our link dataset. Now we can drill down to view the subcommunities within this community. The community at level 4 consists of 2 subcommunities displayed here. We can see that the larger community makes a lot of calls to the smaller community, and that the small community makes fewer calls to the large community. Now we'll drill down to see the subcommunities that the larger community contains. Now we can see the communities at the second level. We'll select the largest node and then drill down to view the communities that comprise it at the first level. Now we can see the communities at level 1. We can drill down one last time to see the individual customers within one of these nodes. Now we'll view the details for an individual customer. An alternative way to view the model results is to select a specific customer node by number, and then view either the full set of links involving the customer, or only the links within the customer's community at level 1. Note that the weight of a node reflects the total number of links the node has. In this case, the number of other customers that the customer has been in contact with. We'll select the customer with the most links. First, we'll display all of the links for the customer. Note that the customers with a red X are those for which the descriptive attributes dataset doesn't have any information. Now we'll view the level 1 community of the customer. Now we see only the other customers that are part of the customer's community at level 1. We can select a customer and drill up to view the community details if desired. Now we're ready to save the model. For this example, we'll save the model to the same location as the data sources. Now we'll apply the model against a new dataset. This will allow us to generate a number of new attributes for each customer based on the information from the social network analysis. Note that the new dataset must be about the same customers that were part of the original dataset. First, we need to select the application dataset. Next, we'll look at a sample of data from the application dataset. When applying a social model, the application dataset must contain a source or customer column and a KXCOM index column, which will be empty for this example. Note that because we used an identifier's conversion dataset when creating our model, the application dataset uses a customer ID column, as in the identifier's conversion dataset, rather than an SRC column, as was contained in our original events dataset. There are several options for how to apply the model. For this example, we'll use default mode, which outputs all of the information about each node and its neighbors. Next, we need to enter a name for the output generated by applying the model. Now we'll view the results. Here we can see a large number of columns, with details about each customer and their communities at each of the levels we looked at in the graphs. Many of these columns are based on data from the descriptive attributes dataset we used when we created the model. Now we'll expand one of the columns so we can interpret what the data means. Each column name begins with SN for social network. The next part of the name identifies the chart that's the source of the data. This is followed by CM for community and C0, meaning that this is information about the customer's community at the lowest level, containing the fewest members. Churn date KX missing means that the column identifies the number of individuals in the community for which no churn date is available. You now know how to use social analysis in SAP InfiniteInsight. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.